I'll introduce our speaker again, of course. He's deeply interested in the foundations of computational intelligence, and he's a zealot when it comes to an open and interdisciplinary research and innovation culture. He has more than 40 publications and more than 100 talks under his belt. He's the technology head of the Siemens Artificial Intelligence Lab in Munich that he founded with his team in 2017. And I hope that he hears me and is here, Ulli Waltinger.
Thanks very much. Yes, I can hear you. Can you hear me okay?
Yes, I can hear you too. I see a slide, and I hope that's what we're supposed to see right now.
Exactly. So first of all, congratulations. You know, this team behind the scene and front of the scene, you did an amazing job. I super enjoyed the Rise of AI event. Amazing event. Thanks very much. And I'm more than honored, folks out there, to talk to you a bit on trustworthy AI in the physical world, actually. My name is Ulli Waltinger, and I present work here from a lot of teams actually out there. Actually working for one of the oldest startups, I guess, in Berlin, isn't it, right? So Siemens. And if we're talking about AI and if we're talking about industrial AI, I guess we are now at the point where, you know, we need to put industrial AI in operation, right? Towards a focus and towards a pervasive use. And if you look in a large corporation, such as I'm devoted to work for, right? You know, as broad the applications are, from energy management, you know, building grid controllers, from putting more autonomy in mobility streams, from what it means actually, you know, bridging the world between simulation and machine learning, what it means actually control optimization, obviously, or, you know, bringing and shipping additive manufacturing to the next level, you know, or robotic systems that, you know, can be more adaptive, more independent to new demands. But obviously also in the shop floor area, right? More throughput, more availability, you know, all these kinds of tracks. And along the line of these use cases, you know, which need to provide some value, right? We can somehow, you know, discriminate between two different application areas. The one is the natural reflex, I guess, self-existence, what we call it. That means like we need to increase the level of machine autonomy. That means, you know, we want to have a depth and a breadth of value and more adaptive, more efficient, right? Cost saving, these kinds of adaptive technologies, you know, on the horizons. At the second is, I guess, the natural reflex as well, right? It's assistance, right? We call that digital companions. So embodying some kinds of capabilities along the line of machine intelligence in certain decision support systems. So autonomy and assistance are maybe the leading principles that we see in the industrial area. Second, obviously, you know, our job, industrial AI, means, you know, we connect the physical and the virtual world. And this is, I guess, the interesting part in there, right? We work with partners which have a whole, you know, install base of industrial assets coming from turbines, coming from trains, coming from compressors, coming from wind turbines, obviously, as well. And the challenge is, you know, how do we connect this asset together, and how do we make sure that the virtual world and the physical world are bridging together? And obviously, data does play a role, right? We are nonetheless, obviously, in a data-driven society somehow, in a, let's say, supervised data-driven society, isn't it, right? But it's also clear that, you know, we will not have the time to actually label all the data in our world that is accessible or not yet accessible, right? So we will move towards what we call the system-driven, you know, society more. So relying more on self-supervision, relying more on that not every data is being sensed automatically. At the same time, we rely heavily, especially in industrial flavors, on expertise, on domain know-how, and so human-driven systems. And I guess, you know, both worlds bring together the implicit and hybrid knowledge, but also the aspects moving further away from the purely supervised, let's say, weak machine learning paradigms. And what helps here, and I think I loved yesterday actually the call, like ecosystem beats, you know, ecosystem beats a strategy. Love that. And I think, you know, the ecosystem of applied research is the core and the key, actually, how to accelerate further, right? Because applied research is, for me, the impact-driven research, you know, not only advancing state of the art, obviously, right? But actually applying and challenging real world challenges and helping enabling to transform these ideas into innovations. And from a geeky perspective, obviously we can say, in research we fix the data and we tune the model somehow, right? We advance knowledge, we find good architectures. Once we identified a great architecture, a great model, we comes to application. And in application, it might be vice versa, right? We fix the model and tune the data. So we apply different data and different applications to a given, computer vision architecture, predictive maintenance architecture, anomaly detection, and so on. And the business impact is driving and defining actually these questions, these research questions applied AI. And it ain't that easy. What's a different impact? What does provide value? We are in current stage far further that is machine learning providing any value? It's a no-brainer, right? It's the questions, what is actually, and I love the notion of the minimal justifiable improvement. What is the right problem to tackle? And this is how you're actually starting, right? From where, why, to how, to what. What is the right problem? What are the right constraints? What number needs to pop up in which dashboard, in which Excel sheet, in which decision-making application that gets you your boni? This is the problem. This is something where does it actually been integrated? So identifying, what is good enough? Is it 1%? Is it 2%? Right? What are the key drivers of the performance? Right? This is such an essential part in identifying it in first place. Don't worry about data in the first place. Worry about what is the right problem. Then the second step is how, in which business process it needs to be integrated, right? And once you have that, then you can talk, okay, what do we need to do in order to enable that, right? So start from the deployed object, and work backwards, not the other way around. Otherwise, you are ending up in the proof, right? In the proof of concept cycle you don't want to have. Second, obviously, data, data readiness. If I talk to partners, all around the corporates, right, they all suffer data. And I mean, with data readiness, hey, for sure, right? It's not we have some data in some CRP, ERP, or asset, right? Data readiness means you are mature enough in access, in delivering, in sharing, and utilizing your data, right? And there's a whole spectrum, actually, what can be considered there. Talk to us or talk to me if you, think about, hey, how do we address data readiness in your corporation? And third, obviously, is about research questions, isn't it, right? And really real-world challenges, drive the applied research direction actually have. And these are, sometimes the blueprints that we use it throughout, I don't know, the last 3 years, and I guess we'll use it also for the next 3 years, right? What's some typical questions we have, and we ask for the, applied research ecosystems and the partners out there is, how do we do with data efficient learning, right? Not every data asset, is being connected, is available, right? What's the role of active learning? What's the role of simulation? How do we do prior knowledge induction? Second, about companion, what is multimodal interaction? What is if we deploy very fastly end to end and then continuously increase the accuracy and the level together with the partners? Third pillar, obviously, explainability is something which, especially in physical domains and physical worlds, is quite important. But also about, the capabilities of, for instance, federated learning, right? Can we distribute? Can we learn from a distributed asset base? Nice. And fourth, obviously, and I think this will be the next 2 years of, trustworthy predictions and reliable operations. So we need to think about safety architectures, about robustness, but also about what it means, industrial trustify grade solutions. So trust seems to be a bit of a role, right? Right. So in simple words, right, we need to talk about industrial grade trustworthy solutions, to be honest, right? Because obviously you have, the AI capabilities, and I love the accessibility of current AI technology, right? Starting a TensorFlow or PyTorch, getting the notebook up and running, easy, nice, done in maybe a couple of hours, right, for most of the stuff. But what it means actually providing value end to end is a bit of a different twist, right? Because in order to solve the right things, it requires some kind of understanding, in what kind of business integration needs to be done. The second is that if it changes the business process, right, it needs to be deployed in a productive system. And this requires trust. If a system automatically triggers some kind of changes in the business process. And obviously, since we don't want to have this one-on-one and we have a continuous loop actually in deploying it, it requires automation on the machine learning capabilities. And this brings us together the industrial-grade trustworthy solutions, a bit more than launching a Python Jupyter notebook. Especially in this industrial AI, the challenge is that we need to make from both worlds actually some benefits. The implicit data, obviously data-driven, insight, but also the explicit stuff, domain know-how being integrated, because the data you seen in the industrial layer, it's not easy to label them, right? It may be cats and dogs for the outer world, but sensor, is it an outlier, is it an anomaly, right? A lot of data is not yet sensed, so brownfield environments, the code, and there's a lot of domain know-how because, we need to have some sense of feeling how is actually moving, how is the physical control, how is the actor actually been moving. So that brings a bit of some challenges in out there, right? And we all know from our daily, I guess, consumer tech experience, machine learning can be truly a fragile beast, right? Obviously, in certain aspects. And for most of the aspects, if we interface on a daily basis with machine learning technology, we don't necessarily expect 100% performance. It's okay if it's rank 2, or if you bring, well, potentially not a rat bell pepper, to your wife because somebody recommended in the store that, this is a good replacement for that, right? It's a bit of fragile, right? And this, I guess, respect the past, but, invent the future. Correlation is not causation, right? Causality is for sure reasons, the last 2 years, one of the key pillars of research, right, in the machine learning departments, right? And I guess it summarizes also like that, Nigel. I love that because this is something how it feels in many cases, right? French is a crazy and a beautiful language. It's spelled different than you speak it, right? The sound of the language is magnificent, but it's somehow a bit of a difference. But still, machine learning, it looks like that, right? You could just, memorizing everything, and that's still, cracking up on the French Scrabble Championship without speaking actually any French, isn't it? And for business, what does it actually mean for us? We demand scalability solutions. That means for sure you can start the POC in a certain factory, right? You can train a model on a certain and apply it in a certain applications. But we actually demand scalable solutions. That means we need to rely on that if we train certain solutions, we can transfer them across different deployments. And that means we need to cope with environmental discrepancies, but also deployment discrepancies, different cameras, different angles, different data, different setup, and this requires quite some push towards robustness and quite some push towards what is called domain generalization. And this is where we also start together with university and with the partners, but also in our own turf, right? It's how do we make sure that, we advance the field of trustworthy predictions, right? If you use softmax, neural network, so you have most of the layers, right? At the end, you use the softmax layers for get some distribution. If you put that out of the main, it does crazy things, guys, right? Isn't it? So how do we make sure that we, get some feedback, right, on the robustness of the applications if you move the machine learning model from one to the other? At the same time, obviously, as we build up this large nets, right, on certain capabilities, right, we need to deploy it in the physical world somewhere on the edge level. And the edge may be a sparse resource edge, right, a sparse resource device which you not consume like megabytes to inference. Nevertheless, right, we need to provide reliable models with a low memory footprint, for years to run. It's also a different question, right? At the same time, obviously, how do we approach that? We're not seeing this 100,000s of events that we have in the consumer space on the ad rate, but how do we actually use a meta learning mechanism in order to come with a few gradient steps, few shot analysis, to a sufficient detection algorithms, right? This is all typical problems that arise in the industrial domain, which we approach and which we also share with the research and academia partners out there. Next level is obviously active learning. Active learning helps us primarily also, obviously, getting feedback done. That means from annotation, obviously, going fast end to end, from data to actually, actuation, but allowing the experts and the partners to seeing and listening, but also injecting their own knowledge. This is an anomaly. This is, just forget about it. This is interest. This is not seen yet, right? And active learning and annotation gives us here, two sides: the domain know-how capturing process, as well as, enforcing a bit more explainability. And I guess we have a lot, heard yesterday already, right, from Hans and so on, about knowledge graphs, right? Yeah, for sure, we are in a huge hype of data management again, right? Remember the big data hype? And yes, knowledge graphs are an interesting and very, very, great and easy to go actually way in digitizing these kinds of domain structures, digitizing information, bridging silos, but it allows us also, to somehow, enter the phase of graph-based machine learning, which is also very nice because it has also the explainability aspects in there, so giving more explainability, and it allows to inject external data to our internal data source. So that's quite interesting aspects. But nevertheless, once you have the methodologies and you work with your partners in there, solving certain kinds of pieces, and then it's shipping it, in operation, right? And in operation is one of the, paradigms is, tightly integrated but loosely coupled. Because open source, yes, plays a vital role, right, in industrial AI, also on the shop floor level or in corporate level. But there will be also always proprietary software you need to dig in. And we don't want to recharge again with this patching of open source, patches that, are adopted somehow as we, the best practice learned from obviously the, big data hype, right? So it's the main idea is highly integrated but loosely coupled. There will be always on-prem stuff going on, right? And that brings actually a new horizon, which I would say is super hard and currently being, put together. It's the notion of, that there is an AI ops, the industrial AI ops twin actually, as a few of deployment and tested in virtual environments, but then also to target to the device of production. We applied similar aspects in the simulation domain, process simulation, product simulation, having a virtual representation before it's actually being constructed in some kind of plants. And I think we need exactly these kinds of twin in an AI ops direction as well. We need to apply certain machine learning capabilities in a simulated, in a virtual environment before we go actually on the target devices. Given this here, which we call the ops twin. And there's many reasons, right, why somehow end-to-end and the POCs, and we had this morning quite feedback already, right, why it's in. I think it's, one of the aspects is, most of the companies I see, they design proof of concepts. Don't go for proof of concept, right? I think we are over that stage, right? Design for the deployment, design the minimal justifiable improvement, design for that, right? Second, obviously, team structures, right? Every company has this, our working students does that. He's the AI ops, he's the business analyst, he's the software engineer, he's, this one-trick pony, right? Thing. Don't do it, right? Bring people together. Ops needs different expertise, from data science to operationalize, from business to customer, right? It needs different capabilities to make use of your team that you mostly have, or use the partners out there. Third one is obviously, technology. Technology, we need best practices, obviously, but we need also to design for repeat certain aspects. It should be not the one thing, we did it once, but it's always, focus on, is that repeatable in the process? And last but not least, I think kudos to Diego here, right? He said, like, machine learning project without an executive sponsors, never see the light, And I think that's some truly thing. A lot of people bring up and say, like, go for the POC, but if you don't have a corporate sponsoring or the decision maker in the, aligned with his values, interests, right? what is we need to do in order that you get your money, right? This brings value statements sometimes on the end. You know, this helps obviously as well, you know, shifting closer to end-to-end integration. And last but not least, right, I think we are talking a lot of data, and I've seen the first pitches already coming on with, you know, we have this magnificent tool, you know, of this unbiased button, you know, what the heck, right? There is no unbiased buttons from my perspective, right? We deal with bias and data. We deal with data, and data is dirty and, you know, biased as it is, right? We can have a closer look, we can monitor, but, you know, it will be always somehow flawed and somehow biased by certain aspects. And this brings us actually to an aspect that's, you know, it's that we need to reflect on the actually applications that we built that are fueled by certain technologies, fueled by certain data, right? Which obviously comes with a lot of capabilities that we have, right? Like visual monitoring allows some transparency, it allows some security, something pretty good, right? Or, you know, process efficiency, or, you know, cost and failure reductions in certain capabilities. But sometimes these, you know, use cases bring also some accompanied by some kind of risks, right? Like, you know, misuse or bias, or, you know, safety, you know, or, you know, intransparencies or black boxes, right? But there are certain mitigation scenarios one, and as you as a decision maker can take, right? Whether it's awareness, whether it's training, whether it's technology, whether it's co-creation, maybe sometimes also regulations, right? In helping to mitigate them. But I think C-level needs some kind of blueprints and playbook, and in order not only seeing capabilities, but also not only seeing risks, but actually, you know, having a playbook of awareness, how to approach certain use cases, enabling and mitigating risks. And this brings me actually to the key takeaways, I guess, right? And the famous three, right? AI models, obviously, you know, easy to prototype. It's super, super nice, you know, the accessibility of machine learning methodology. I love it, right? But it's a different if you maintain it in production, but you go for end-to-end. This is, you know, even though you're not having the highest accuracy, continuous improvement needs to be targeted, but it needs to go end-to-end, otherwise you don't do it. Second, I'm a geek. I love tech. I love exploring technology, but favor for business-driven innovation. What is the minimum justifiable, you know, improvements you want to have? And define what you don't do, right? Especially in large corporates, right? You know, there is a tendency of not defining what you don't do, because if you know exactly what you don't do, you can leverage this awesome, you know, ecosystem of which has the speed and scale that you actually need. And third pillar, you know, is trustworthiness, explainability, robustness, but also security, you know, will be the imperative in industrial AI, right? And I'd love to engage with you further. You know, ping me on the books or on the email or on LinkedIn. More than happy to engage with you together. Thanks very much.
Ulli, thank you so much. I think I have a couple of questions for you already, although we only have a couple of minutes time for them. But I was quite curious. You dared to say there is no unbiased data, right? And I think that made many people quite nervous, I think, because they're striving for unbiased data. Maybe some people in their companies told us, no, of course we can remove bias from data. On the other hand, you were talking about explainability. And I think there are some people who would say there is also not a completely explainable AI. What do you say to that?
Yeah, let's tackle bias first. So, you know, bias is there's always bias. I think there's a great tooling in there, which helps sheds a light. How is your distribution of the data? Yeah. How is the coverage? Is it only dogs, or are there some random cats in there as well, right? Stuff like that. Right. Or, you know, what kind of features are being used, right? Is gender included, right? Or is gender explicitly excluded, right? But it also goes in the direction even so if you have in the training material, you know, in your training set of smart applications being said like, okay, I think it's a bit of a representative what we actually target, then it hits the real world and different data comes in there, right? And so I think, you know, if you talk about reflecting on the bias or on the fragility of machine learning modules, it's also clear that it doesn't stop with just the training, but it's a continuous, and that's why we call it, you know, the AI ops twin. It's a continuous monitoring what's going on here, and to make sure, we're aware of the implications that it can have. Second aspect, explainability, right? And yeah, for sure, there was quite some hip, and they're like, neural networks are these black boxes, and I don't know, get what it's in there and stuff like that. And that's why we don't use them. There are tools and technologies around there, and there are certain, obviously, pieces, where a transparency, and this is, I guess, what most demands in terms of explainability. I totally agree with explainability, but transparency, right? I have currently no clue what my wife is doing. I surely trust it. I trust her. We will do okay. I don't have transparency about what she's currently doing. But in certain pieces, right, we need to invest and say, like, why certain decisions are being made. And there are different versions and different actually instruments. We can enforce a bit more explainable features, what it has learned, how it behaves post-mortem, how it was trained, how it's applied. But also maybe, combining different explainable and non-explainable models and having a bit more closer. So I don't see it as, it's if you're using neural networks, everything is black box. It ain't that. So there are measures to, work together.
Right. Thank you. You were making a strong case for making business-driven AI decisions and not tech-driven AI decisions. But at the same time, we have been talking a lot about the proof of concept graveyard, right? I presume that probably the decisions to do a proof of concept are all tech-driven, right? People want to experiment, want to see if anything goes, and because there is no business decisions driving it, then the whole thing stops. But is it really a good thing to demand business-driven decisions? Because maybe people will just stop developing AI solutions then because they don't see the business case yet. Maybe they're not confident enough that they will have a successful end-to-end integration. What do you think?
Yeah, but I still go for that. So obviously, lessons learned out of the big data hype. I don't know. You remember that? we had some cases there, right? Some lessons gone there. So the natural reflex of management was calculate me the business case. If it's not making a double-digit impact, right? We ain't gonna go there. Right? And that killed everything, right? And now they actually put out and say, like, yeah, here's toy, go it, right? But ain't gonna have a business impact. We need to understand from the mindset, right? This is not a totally magical tool, but if you're thinking on the AI first, it has a pervasive use in various the quantity of applications, right? Will bring the entire business together. And that's why, I still urge C-level, you need to understand this is not a holy grail, but it will, any different process and any given product, there will be not AI in there, right? So you want to start now or you want to start later? This is the only question, right? And if we start now, let's talk about the minimum justifiable improvement you want to make. What does a certain application need to move that you get your bone in, right? This is the question to ask. And then you work backwards. And I think that helps. You design for production, not for POC. The time of we're testing out, it's a nice, let's do a bit ImageNet competition on certain kind of devices is over. Let's do business.
Then I can only say thank you very much, Ulli. And I hope that you will be able to convince many people that the time is now. Thank you.
Thanks very much. Cheers.
Thank you. Bye-bye.